So next we'll see the next part, subsets. Now what is this subset? Suppose A and B are two sets, and if all the elements of A are in B, if all the elements of A are in B, then we'll say that A is the subset of B. Suppose all the elements of B are in A, then we'll say that B is the subset of A. So subset means what? All the elements of one set will be in the other set. If all the elements are in that set, then we can say that the first set is the subset of other set, and we represent it as A subset B. It is the representation of subset A subset of B, that is the sign of subset. So similarly, if A is subset of B, we say that B contains A. It means what? All the elements of A are in B, means B is containing the set A, so B will be the superset of A. So B is the superset of A and A is the subset of B. If all the elements of A are in B, then we say that A is the subset of B and B is the superset of A. So this is the sign of superset, B superset of A, and this is the A subset of B. Next we'll see what are the applications of this. So I have given one example. Set A contains the element 1, set B contains 1 to 3, means all the elements of A are in B, so we'll write that A is subset of B. Now A is equal to 1 comma 4 and B is 1 to 3. Here 1 is here, 1 is also here, but 4 is not in the set B, that's why I will write that A is not the subset of B. So subset means all the elements of set A will be given in the set B, that's why only in that case we can say that A is the subset of B, otherwise it is not the subset. Next I have written a note. Natural number is subset of integers. Integers are the subset of rational numbers and rational numbers are the subset of real numbers. So we can say that real number is the superset of natural number, integers and also rational numbers. That's why natural number n is represented as natural number, z is integers, q is rational number and r is real number. So natural number is the subset of integers is the subset of rational numbers, and rational numbers are the subset of real numbers. So you can say that real numbers are the superset of every set. So now next I have written every set is subset of itself, means A is the subset of A because A contains A. If I write A is equal to ABC, then I can say that A is subset of A because A is containing that set A. So that's why A is subset of every set is subset of itself. Next, the empty set is subset of every set. Phi, remember phi is the subset of every set. Phi is the subset of every set because phi means what? It is the null set, and suppose set A means there is no element of phi in A, and then that's why we can say that phi is the subset of A. Next, the total number of subset of a finite set having n elements is 2 to the power n. Means how will you find out that a set is having how many number of subsets? So the formula is 2 to the power n, and n is the elements of that given set. Suppose set A is given 1 2 3. The elements are given 1 2 3, so it is asking find the subset of number of subset of this given set. So we'll write 2 to the power 3, that is equal to 8. How it will be 8? So first will be phi, as I told you that phi is the subset of every set, so phi. Next the number 1, then 2, then 3, then I can write 1 comma 2, then I can write 1 comma 3, then I can write 2 comma 3. See, 1 comma 3 or 3 comma 1 are the same thing, so you cannot write both at the same time. So and last I told you that every set is a subset of itself, so 1 2 3 is also the subset of that set. So 2 to the power n will give you the total number of subset of that given set, 2 to the power n. So here we have to remember three things. Every set is subset of itself, phi is the subset of every set, and if you have to find out the number of subset of a given set, then the formula is 2 to the power n, and n is the number of elements. Next we will see the power set. Now what is this power set? So last week I told you about the subset number of subset of a given set. So if we will collect it in a set, then that set is called as a power set. So let A be a set, then the collection of the family of all the subset of A is called the power set of A. It means the collection of all the power set, all the subset of the set A is denoted as power set, and it is also denoted, we can denote it as P of A. P of A means I am talking about the power set. Suppose let A is given to you one set A comma B. So how many the total number of subset will be 2 to the power n, that is 2 to the power 2, which is equal to 4. So that are the subsets are phi, then A, then B, then A comma B. So power set will be phi A, B and A comma B, and it will be in a bracket as we are representing in a set. So power set means what? The family of all the subset of a given set is said to be the power set. Next, universal set. Suppose if I will give you one small example, as you all are studying in a particular, some are reading in A school, some are reading in B school, some are reading in C school. So you are the part of that school, means you are in that school. So that school will be known as the universal set. So there is always a set that contains all the set under consider. As you are studying under me, that's why I will be the universal set, and you are part of my organization. That's why I am the universal set, and you are the parts of that set. Suppose I have written A is equal to 1 2 3, B as 2 4 5 6, and C as 1 3 5 7. So if we'll see, I have written universal set U is equal to 1 2 3 4 5 6 7. It means it is containing the set A, it is containing the set B, and it is also containing the set C. That's why it is known as the universal set. So these are the all types of set that I have told you.